Welcome to mathematics. This is Mangeya, the maths eagle. Right. This part is on advanced level statistics for Cambridge International AS and A level. Probability and Statistics 1. That's paper 5. It's for May-June 2021. That's the question paper, past exam paper. Then, after watching this video, please subscribe, like and share this nice powerful video. Mangeya signing in. Let's get started. Question number 1. A bag contains 12 marbles, each of different size. 8 of the marbles are red and 4 of the marbles are blue. How many different selections of 5 marbles contain at least 4 marbles of the same color? Right. This one is called a combination, since we are selecting or we are choosing. So whenever we are choosing or we are selecting, that's what is known as a combination. Then whenever we are arranging in a certain order, an arrangement is called a permutation actually. So this one is a selection, is called a combination. We have to use combination choose. Right. A bag, in total there are 12 marbles, each of different size. 8 of the marbles are red, 4 are blue. How many different selections of 5 marbles? So we want to make a combination of 5 marbles. At least we contain at least 4 marbles of the same color. The combinations here, it can be, we can start by taking from 8, maybe 5 of the red and 1 blue, 4 red and 1 blue. 4 red and 1 blue will make you 5. So total will be 5 here. Or we can say 5 red and 0 blue. We still get a total of 5. Or we can take all the 4 blues and 1 red. We can still get 5. So these are the different combinations that we have, right? In this case, how many selections can we be able to make? Right, from 8 we have 8 red. From 8 red we can choose 4, and from 4 blue we can choose 1. 4 plus 1 is 5. Then plus we can choose that this first. Then this one now we can choose 5 red and 0 blue. From 8 we can choose 5. Then from 4 we can choose 0. Still it will be 5. Or we can choose this one. We can choose 4 blue. We can choose 4 or 4. From 4 blue we can choose all the 4, and that's times 1 from the 8 to make them 5. Then punching in your calculator, what we get here, 8 choose 4. 8 choose 4 times 4 choose 1. 4 choose 1 plus 8 choose 5 times 4 choose 0 is 1 plus 4 choose 4 is 1 times 8 choose 1 4 choose 4. You get 344 ways. So these are selections that can be made, right? So that's the answer. Next question, question number 2. A company produces a particular type of metal rod. The length of these rods are normally distributed with mean 25.2 centimeters and standard deviation 0.4 centimeters. A random sample of 500 of these rods is chosen. How many rods in this sample would you expect to have a length that is within 0.5 centimeters of the mean length? Within 0.5 centimeters, then is plus or minus 0.5 centimeters. Mean length is 25.2, so it's plus or minus 0.5 centimeters. So the lower bound and the upper bound obvious is 25.7, so you add 0.5 to 25.2, then lower bound you subtract. It's supposed to be 24.7, 25.2, just to confirm, minus 0.5, yes, it's 24.7. Right, these are the upper and the lower bounds based on this information given. Right, so first thing, we have the length of the rod here in this case. What you have to do is to find the probability or the percentage of those whose length lies between or within 0.5 centimeters of the mean length. After that, you multiply by 500, the number of or the symbol that has been chosen. So first thing, you say let x be a random variable. This x is not supposed to appear from nowhere. You have to let it first. Let x be a random variable. Then the length of the rods. So x will represent the length of rods in this case. From that, we can deduce that x will follow a normal distribution with mean 25.2, a standard deviation 0.4 squared was its variance. Remember, x follow a normal distribution with mean mu, a standard deviation squared, that is variance. Then after that, let's find the probability that the values lies within 0.5 of the mean length. It will be probability of, we say 24.7 less than x less than 25.7. So that's the range under which these values lie. Then standardizing using z is equals to x minus mu over sigma. It will be a probability of 24.7 minus mu, which is 25.2 over sigma 0.4. That's the standard deviation. Then you convert x to standardized z. Then 25.7 minus mu, which is 25.2 over sigma 0.4, like this. Then after that, go further. 24.7 minus 25.2 is actually negative 0.5. So negative 0.5 divided by 0.4, you get 1.25. So its probability negative 1.25. Z lies between negative 1.25. This part will also get positive 1.25 because it's the same. It's the same actually. Right, then drawing your normal distribution graph, symmetrical about the mean mu. This one will be 0, standardized mean 1.25. Then this side will be negative 1.25. So the area needed is this one. That's the area of probability that we are looking for, right? Then, for the formulas that we are supposed or going to use in this case, you can check. There is my YouTube video that I've done is there at my YouTube channel at Laxon Mangeya. Is there on my YouTube channel at Laxon Mangeya. You can look for that video, how to derive formulas involved in normal distribution. Find it is there. Right, for this one, you say 2 far of A, which is 1.25 minus 1. So probability that Z lies between a positive and a negative number, these are the same, right? Usually say far of A plus far of B minus 1. That's probability of Z lies between two, a positive and a negative value. Far of A plus far of B minus 1. Then, so since they are the same, far of A, it will be 2 far of A minus 1. Find it. My video is there. Then now, it will be 2. Far of A, which is far of 1.25, you consider your normal distribution tables. You find 1.2 under 5. 1.2 under 5, the normal distribution table is here. 1.2 is here. Under 5, 0, 1, 2, 3, 4, 5. In this value, 0.8944. 0.8944 minus 1. Subtracting this one, you get 2 brackets 0.8944 minus 1, you get 0.7888. 0.7888. So this one is the probability or the percentage, which can be called 78.88% of the values. So now to find the number, you multiply this number 0.7888 times 500 of the rows, then multiply by 500, 394.4, or you can just write 394 rows, or even 395. It works. Right, next question. Question number 3. How many different arrangements are there of the 8 letters of the word released? Arrangements, in this case, there is no restriction, right? So you just work without restriction. You just count the number of letters here. 1, starting from R, then 2, 3, 4, 5, 6, 7, 8. So there are 8 letters as written here. You write 8 factorial over, then the repeated letters we have 1, 2, 3 is represented. So you say 3 factorial to represent the repeated letters, right? Are there any repeated letters? As you can see, there's nothing, right? Let's say if there were 2 more repeated letters, we're supposed to say 3 factorial times 2 factorial, then you can find the number of ways. But in this case, nothing. You just say 8 factorial divided by 3 factorial. 3 factorial. Then you get 6720. So these are the arrangements that can be made. Done. Question number part B. How many different arrangements are there of the 8 letters in the word released, in which the letters LED appear together in that order? Right. The LED one is fixed. LED is fixed here. We treat it as one item since it's fixed, right? There's order. Then you find the number of ways of arranging the other remaining letters. What will be left here is R. We have another E here, and we have an A. We have an S, and we have another E. 1, 2, 3, 4, 5, 6, 7, 8. So this one you treat it as one item. It's a single item. Then it will be 1 here, then 2, 3, 4, 5, 6. So there are 6 items in this case. So you say 6 factorial over, then we have 2 is, repeated is 2 factorial. That will be it. Then these letters LED can only be arranged in one way, since they are already, the order is already given. So it's one way. You just say 6 factorial divided by 2 factorial. You get 360. So 360 different arrangement that can be made. Done. Next question. Part C. An arrangement of the 8 letters of the word release is chosen at random. Find the probability that the letters A and D are not together. Right, not together. Let's find the ways first. But the easiest way of working out something like this is to find the ways in which they are together. Then to not together, you just subtract from the total number of ways available. Right. So let's calculate in this case, given that they are together. Or first, the number of all possible outcomes, given that there's no restriction. So number of all possible outcomes. Right, you just count here. 1, 2, 3, 4, 5, 6, 7, 8. is 8 factorial over repeated, we have 3 is over 3 factorial. This one the same as what we have done here on the first part. So we must get the same answer, 6720. 6720. These are the all possible outcomes, right? Given that there is no restriction. Now, given that A and D are together, right? We put them together like this. Then after that, we find the number of ways of arranging the remaining letters. So E, R here, then we have E, we have L, we have another E, we have S, we have another E. 1, 2, 3, 4, 5, 6, 7, 8. There must be 8 in total. So given that they are together, I've combined them together. How many different ways in this case? We can say this one AD, we treat it as a single item. Then 2, 3, 4, 5, 6, 7. So it will be given that A and D are together. The number of ways will be 7 factorial over, we have 3 E's that has been repeated here, over 3 factorial, then times the number of ways of arranging A and D, right? Because remember, A and D, they are not fixed. We can start with D, we can start with A. So that's the number of ways. You can say 2 letters, then it will be 2 factorial. The number of ways here, 7 factorial divided by 3 factorial times 2 factorial, you get 1680. So these are the ways, given that A and D, they are together. Then not together, you say total ways, which is 6720, minus the number of ways that they are together. Then you can get minus 6720 5040. Then the probability now that they are not together is equals to, say, 50, the number of ways of not together, divided by total number of ways, which is 6720. What we get here, three quarters or 0.75. We can write 3 quarters, still is the same thing. Right, next question. Question number 4. To gain a place at a science college, students first have to pass a written test and then a practical test. Each student is allowed a maximum of 2 attempts at the written test. Written test, a maximum of 2 attempts. A student is only allowed a second attempt if they fail the first attempt. No student is allowed more than 1 attempt at the practical test. If a student fails both attempts at the written test, then they cannot attempt the practical test. The probability that a student will pass the written test at the first attempt is 0.8. If a student fails the first attempt at the written test, the probability that they will pass at the second attempt is 0.6. The probability that a student will pass the practical test is always 0.3. Draw a tree diagram to represent this information, showing the probabilities on the branches. Right. To gain a place, the student has to pass a written and then a practical test. Each student is allowed a maximum of 2 attempts at the written test. So first is a written, then after that a practical test. So a student is only allowed a second attempt if he fails the first attempt, right? So from that statement, we can deduce that a student here, let me use this one to represent the written test, or the first part. So you can either pass written test, let me use PW, so pass written, that's PW, that's my key. Then fail written, that's FW. So it's pass written or fail written, like this. Then it's either you can pass written or you can fail written, right? Then a student is only allowed a second attempt if he failed the first attempt. So failing here, he can get another chance, this student, and this chance he can either pass this written or he can again fail the written, right? Then next, as a student is only allowed a second attempt if he fails the first attempt. No student is allowed more than one attempt at the practical test. So practical is 1, only written 2 attempts. If a student fails both attempts at the written test, then they cannot attempt the practical test, right? So fail cannot attempt. So in this case, let me fill this part. So if we can pass the first attempt, then this student will go straight away to the practical test. So practical test, this one, practical pass, practical test pass, then practical test, then he can fail, that the practical test fail, right? So PW means fail practical test, PP means, or let me write in full. So this one pass practical, that is PP, then fail practical, that is FP, right? Then this part also, if we can pass the practical, the written, then he can also either pass practical or he can fail practical, like this. So that's the tree diagram basically. Now we have to fill in the possible outcomes here. In this case, the probabilities. The probability that a student will pass a written test at the first attempt is 0.8, which means failing is 1 minus passing. 1 minus 0.8 is 0.2. So it's either you pass or you fail. Passing and failing is equals to 1 if you can add the two. If a student fails the first attempt at the written test, the probability that they will pass this at the second attempt is 0.6. Second attempt is 0.6, which means failing is 0.4. Then the probability that a student will always pass the practical test is always 0.3. So pass practical is always 0.3, which means failing practical is 0.7. So pass here 0.3, failing 0.7, pass here 0.3, failing 0.7. This will be your tree diagram, right? So that's your tree diagram. Done. Next question. Find the probability that a randomly chosen student will succeed in gaining a place at the college. Right? Succeed is either he pass the written, then he pass the practical, or he fail the written, he pass the written, then he pass the practical. So he passed the written on the second attempt, then he passed the practical. That's the student being admitted or succeeding in this case. So it's this one. So it's either he can pass written, probability of pass written, and then pass practical, or that is plus he can fail written. After failing written, then he can pass written, second attempt, then after that you can pass the practical. So they have to pass the practical to be admitted. First part, pass written, you can see here is 0.8, then pass practical 0.3. 0.8 times 0.3, 0.8 times 0.3, then plus this case pass written, fail written 0.2, pass written 0.6 per first attempt, Then pass practical is always 0.3. Then from this you can find the probability that a student is admitted. Then it says 0.8 times 0.3 plus 0.2 times 0.6 times 0.3. You get 69 over or 0.276. 0.276 or 69 over 250. Still it works, right? So these are the two answers. Next question. Find part C. Find the probability that a randomly chosen student passes the written test at the first attempt, given that the student succeeded in gaining a place at the college. So we are being asked to find the probability that he passed the written test at the first attempt. So pass first attempt, given that he succeeded in gaining the place. Using conditional probability, it will be probability of pass first attempt intersection succeeded in getting the place over probability of succeeded. That's conditional probability. There's also another video on my YouTube channel based on conditional probability, specifically conditional probability. Probability of A given B is probability of A intersection B. That's conditional probability over probability of B. So that's the same concept that I have applied in this case. So pass intersection succeeded, it will be first attempt is here. Tree diagram is 0.8 and 0.3, right? So 0.8 times 0.3, 0.8 times 0.3 over, that's pass intersection succeeded over. Succeeded, we've worked it out, is here. Is this one 0.276, 0.276. Then using a calculator, you can say 0.8 times 0.3 divided by 0.276, 20 over 23. 20 over 23, that's the probability. Or you can, to three significant figures, 0.8695, so it's on 0.870. To three significant figures. We can say done. Right, next question. Question number 5. The times taken by 200 players to solve a computer puzzle are summarized in the following table. Time t seconds, number of players, that's the frequency. Draw a histogram to represent this information. Right, histograms, there are two different dimensions. We have equal class width and unequal class width. When there is equal class width, we use frequency on the vertical axis and the horizontal will be the same. But if the class width or class difference is different, then we have to calculate what is known as frequency density. Right, so in this case, let's check. Class width from 0 to 10 is 10 minus 0 is 10 here. 10 to 20 is 20 minus 10 is 10 here. 20 to 40 is 40 minus 20 is 20 here. You can see the class width is now different. So it means you have to calculate frequency density here. So if I can add another column here, another row. Right, this row is for frequency density here. Let me put it here. So frequency density, which I can write FD. Right, frequency density, how do you calculate FD? Frequency FD, we say frequency over class width. Over class width. Class width is same as class difference. Class width or class difference, yes. So for example, for 0 to 10, for class 0, t lies between 0 to 10, you can say Frequency is 16 over class difference is 10 minus 0. So in this case, you get 1.6. So this one will be 1.6. Like this. Then for 10 to 20, you say 54, that's frequency, divided by 10 to 20 is actually 10. 54 divided by 10 is 5.4. Then next, for 20 to 40 is 78, divided by 40 minus 20 is 20. You get 3.9. Then for 40 to 60, you say 32, divided by 40, 60 minus 40 is 20, 1.6. Then for 60 to 100 is 20 divided by 40 is 0.5. Done. So now we have our frequency density, right? On the vertical, we have to put frequency density here. Then on the horizontal, you have to put time in seconds. On the horizontal, so it's time. Labeling your graph, very, very important. So please take note. Then now going up to a table, the horizontal is 0, 10, 20. So it's from 0 to 100. We can use a scale of 10, 20 or 20, 40. Let me see the scale here. Right, the boxes we can use 20, 40. 2 centimeters to 20 units. So it's 20 here. Then 40 here. 60. 80. Oh, what is this now? 60, then 80 and 100. No 90 here. 100. So this one is 80, this one is 90, 60, 50, and this one is 20. Right, done. Then on the vertical axis, you put frequency density. The smallest value is 0.5. The highest value is 5.4. Let's choose an appropriate scale. You can use 1, 2, 3, 4, 5. Let me see the boxes. Right, you can use 1, 2, 3, 4, 6. So this one will work. This one will work. Because it's 5.4, that's the highest value. Then going up, right, 0 to 10 is 1.6 frequency density. 0 to 10 is 1.6. So you go down here, 0 to 10 is 1.6. 1.6 is, right, on the vertical, to find out each small box, how many units does it represent? You say 1 here, divided by the number of boxes, from this point to 1 is actually 10 boxes. Divided by 10, so it will be 0.1 units, right? That's on the vertical. Horizontal, you say 20 divided by 10, 20 divided by 10, so it means each small box represents 2 units on the horizontal axis. Right, the vertical, we want to find 1.6. 1.6 here, so it will be 1, then point 1, 2, 3, 4, 5, 6 is somewhere here. Then to 10, that's it. You put your bar here, then you can say done. Next, 10 to 20 is 5.4. 10 to 20 is 5.4 here. 5.4, 5.1, 2, 3, 4. It's here. That's 10 to 20 here. You put your bars. Next, 20 to 40 is 3.9. 20 to 40 is 3.9. 3 here. Point 1, 2, 3, 4, 5, 6. Just subtract 1 from to 40 here. So just subtract 1 box from 4. That will be 3.9. Next, 40 to 60 is 1.6, and 6 to 100 is 0.4. So 1.6 and 0.4, 1.6 the same as 60 to 4, 40 to 6, and 0.5. That's 6 to 1. Then you can say done. That's the histogram. Next question. Calculate an estimate of the mean time taken by these players. Mean first thing you find midpoint. For example, for a class 0 to 10, you say 10, 0 plus 10 divided by 2, which is equal to 5. Let me go up this so that you can see it properly. Right, if I can remove this part and replace with midpoint here, this one I write midpoint. 0 to 10, it says 0 plus 10 divided by 2. 0 plus 10 divided by 2 is what? It's 5. Next, 10 plus 20 divided by 2 is 15 here. 20 to 40 is 30 here. Midpoint here is 50. Here is 80. Then you now multiply midpoint times the frequency, right? So the first part is 16 times 5, 54 times 15. 16 times 5. We are using the formula mean is equals to summation of frequency times the value of x over total frequency. Then the third one, 54, 15. The third one is 30 times 78 and 50, 32. $50 times 32. Next, 20 times 80. 20 times 80 over total frequency. Total frequency up there is 1654.78. 1654.78. Actually, it's 200. It's supposed to give you 200 things, right? Then after that, you just use your calculator over 200 here. You punch 16 by 5 plus 54 by 15 plus 30 times 78 plus 50 times 32 plus 20 times 80. 6430 divided by 200. 32.15. To three significant figures, 32.2. Then you can say done. Right, next, find the greatest possible value of the interquartile range. Right, interquartile range, I'll just write the formula here. That's upper quarter, which is Q3 minus Q1. That's upper quartile minus lower quartile. The next question, question number 6. In Kester, 60% of the adults travel to work by car. A random sample of 12 adults from Kester is taken. Find the probability that the number who travel to work by car is less than 10. Right, in this case, you can see it's a binomial distribution, right? Why? Because there's P, that's the probability of success, 0.6, 60% is 0.6. Then you have N, which is 12. So whenever there's N and P, that will be a binomial distribution. Right, from there, you can say let X be a random variable. Let X be a random variable. This one is the what? Travel to work by car. The number who travel to work by car. The number of people who travel to work by car. Then from that you can say X then will follow a binomial distribution with NP. N is 12 and P 0.6. From this we can find Q. The probability of success of failure is 1 minus P, which is 1 minus 0.6, which is equals 0.4. That's Q, right? Then we want to find the probability that the number which travel to work by car is less than 10. Less than 10 is probability that X is less than 10. Right? This one, less than 10, it can be from 0 to 9. 0 probability of X equals to 0 plus 1 plus 2 plus 3 plus 4 up to 8. You die a death. You die a death. This is serious. Right? Don't attempt that at home. So please don't try this at home. What you have to do actually is to work from 10 to 12. Then you say 1 minus probability of X greater than or equal to 10, which will be 1 minus probability of greater than or equal to 10 is probability of X is equals to 10 plus probability of X is equals to 11 plus probability of X is equals to 12. Then in this case, you will not die. It will be powerful actually. Right, then you say 1 minus probability of X is equals to 10. Let me put a bigger item here. Is actually N choose, which is 12 choose X. These formulas will be there in your formula booklet, right? It's for the binomial expansion, binomial distribution. Then you say Q. Where's your Q? 0.4 to the power 12 minus 10, which is 2. Then P 0.6 to the power X, which is 10, plus, right, X equals to 11 is 12 choose 11. 12 choose 11, then 0.4 to the power 12 minus 11 is 1. Then X 0.6P to the power 11, then plus 12 choose 12, that's probability of X equals to 12. Then we have 0.4, that's your Q to the power 12 minus 12 is 0. Then we have our P 0.6 to the power 12. We can say done. 1 minus, then you simplify inside here. 12 choose 10. 12 choose 10 times 0.4 squared times 0.6 to the power 10 plus 12 choose 11. 12 choose 11 times 0.4 to the power 1 is 0.4 times 0.6 to the power 11. Then plus 12 choose 12 is actually 1. So in that case, 12 choose 12 is 1. 0.4 to the power 0 is 1. So this one just be 0.6 to the power 12. Then you get 0.08344332. You just subtract from 1 minus 1. You get 0.917 to 3 significant figures. Then you can say done. Next question. A random sample of 150 adults from K star is taken. Use an approximation to find the probability that the number who travel to work by car is less than 81. Right, in this case you can see N is now large, the number of adults. So since N is greater than 30 is large, then and NP, let's find NP and NQ here. If NP is greater than 5 or NQ greater than 5, use normal approximation. NP is 150 times P, which was 0.6. 1/5 times 0.6 is 90. Greater than 5, so you can use a normal approximation to the binomial distribution. Then NQ 0.4 times 1/5, 60. So you can use the normal approximation, the binomial distribution. From that we can say X follows a normal with mean NP and variance NPQ, like this, which means X will follow a normal, NP, that's 90, NPQ is now, NQ is 60, so it will be 60 times 0.6, which is 36. Done. Then you want to find the probability that those who travel to work, find the probability that the number who travel to work by car is less than 81. Probability that X is less than 81. Probability that X less than 81, it will be equal to probability standardized Z less than 80. In this case, basically, you have to first before that. Before standardizing, whenever you use an approximation, remember to use continuity correction. So if it's less than 81, so it's supposed to be less than 80.5. Right? So now we can standardize. Probability of X less than Z now is standardized to Z. Z less than 80.5 minus mean, which is 90, over sigma, which is root of 36. Put a big P, like this. Then simplifying, it will be probability of Z less than 80.5 minus 90, you get negative 9.5, then divided by root 36, which is 6, then you get negative 1.5 under 8 common difference 3. Let me take it like this, 1.583. Right, then after that, using our normal item, we can draw our diagram here. 0, negative 1.583, then it's less than, which means is this area needed? This area, so less than, it will be 1 minus far off. 1 minus far off, with the smaller area, 1 minus far off A, which is equal to 1 minus far off 1.583. Then on your tables, 1 minus, you look for 1.5 under 8 common difference 3. 1.5 under 8 common difference 3. 1.5 under 8, 1.5 under 8, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. 1.5 under 8 is that one. Common difference 3. 3 is up here. So on this line, so you look at this line, you have to add 4. So it will be 0.9429 plus 4. 9429 plus 4. Then you add here plus 3 carry 1. 3, 4, 9, 0. So it's 0.9433. If you can simplify this one, subtract 1 minus 0.9433, 0.0567. Then you can say done. Justify your answer. NP greater than 5, NQ greater than 5. Then you can use a normal approximation to the binomial distribution. Question number 7. Shama knows that. So this one is Shama. She knows that she has 3 tins of carrots, 2 tins of peas, and 2 tins of sweet corn in a cupboard. All the tins are the same shape and size, but the labels have all been removed. So Shama does not know what each tin contains. Shama wants carrots for a meal, and she starts opening the tins one at a time. chosen randomly until she opens a tin of carrots. The random variable x is the number of tins that she needs to open. Right, so Chama knows that she has 3 tins of carrots. Number of carrots, there are 3. Then peas, there are 2. Sweet corn is 2 in the cupboard. So in this case, it's either she has to open carrot or, so it's carrot and not carrot, right? So you can say probability of carrot is actually 3 over total is 3 plus 2 plus 2 is 7. Then probability of not carrot is 2 plus 2 peas or sweet corn. So 2 plus 2 is 4 over 7. So show that the probability of x equals to 3 is equal to 6 over 35. X is the number of tins that she has to open. So in this case, she's supposed to open 3 tins for her to be able to get a carrot tin. Right, so it will be probability of, it will be the first must not be carrot, the second must not be carrot, and the third will be carrot. So it will be not carrot is 4 over 7 times not carrot, and this one, remember, is without replacement, but if she can pick one, then she opens it. It's not replaced, right? Then she pick another one. So in this case, one has been picked from those not carrots. So the remaining will be 3 over total 6. Then the last one will be the carrot. But the carrots now will be 3 over total, there will be 5 tins altogether. Then simplifying this one, 4 over 7 times 3 divided by 6, that's 0.5, times 3 divided by 5, you get 6 over 35. So that's shown. Done. Next question, draw up the probability distribution table for x. Right, this one now, if you can check here, how many columns will you need actually? Right, so the first is either she can open the cupboard, then the first can be carrot, or the second can be carrot, or the third, or the fourth. You see? Oh, so she can open 1 tin, or she can open 2 tins, or 3 tins, or 4 tins, or she can open 5 tins in this case. What's all the peas? Because she can open all the 2 for peas, and all the 2 for, and the fifth one will be the carrot, right? So there are supposed to be 5 items in this case. Right, so we start here. First, 1, probability of 1, x is equals to 1. 1 tin, it will just be 3 over 7, right? Because there are 3 tins of carrots. Then probability of x is equals to 2. 2, it will be equal to, first is no carrot, and then carrot. So it's probability of not carrot plus carrot, then and carrot on the second. So it will be not carrot is 4 over 7 times carrot, it will be 3 over 6. Then if you can simplify this one, it's 2 over 7 actually. Because it's half, then into 2 over 7, yes. Then next probability of x is equals to 3. That's the one that we found there, is 6 over 35. Then next probability of x is equals to 4. Let me write it here. X is equals to 4. Then this one is probability of first is no carrot, then carrot last. So this one, it will be no carrot is 4 over 7 times no carrot, there will be 3 over 6 times no carrot, there will be 2 left over 5 times then carrot, there's 2 be 3 carrots over, but what will be remaining, it will be 4, right? So this one, it will be 4 divided by 7, 4 divided by 7 times 0.5, which is 3 divided by 6 times 2 divided by 5 times 3 divided by is 3 over 35. Then last one, probability of x is equals to 5 tins. Right, this one will be probability of no carrot, no carrot, no carrot, no carrot, then carrot. The fifth one will be carrot, then is the most no space. Okay, so it's just supposed to fill. Right, then here it will be no carrot is 4/7 times no carrot, 3/6 times no carrot, 2/5 times no carrot, 1/4 left times carrot, the 3 remaining over 3, right? So this one, if you can simplify, what we get here, 4/7, 4 divided by 7 times 3 divided by 6 times 2 divided by 5 times 1 divided by 4 times 1. Then you get 1/35. 1/35, then we can say done, right? So we can say done. Then drawing our probability distribution table, we can, let me use this line. We have 1, then 2, up to 5, 3, 4, then 5. This one will be x, the number of teens. Then probability of x is equals to x. Like this. Then probability of x equals to x, you check here. We can start with these are these values there at the end. X equals to 5 is 1/35. X is equals to 4 is 3/35. X is equals to 3 is 6/35. X is equals to 2. 2 is 2/7. Then 1, 3/7. 2/7 and 3/7. Then we can say done. If we can add all these probabilities, you must surely get 1, right? You must surely get what? You must surely get 1. If you can add these probabilities, you add 0.3, all these probability of x equals x, you must get 1. Take note of that. Right, then next part, find the variance of x. Find the variance of x, that's var of x. Variance of x, you say var of x is equals to, is e of x squared, that's the formula, minus e of x, that's the mean, squared. Then e of x squared is equals to, is x squared times summation of x squared times probability of x is equals to x. Then e of x is equals to summation of x times probability of x is equals to x. Right, let's find e of x squared or e of x first. Right, you say x times probability of x is equals to x. We have the things here. So what is our x here? We say 1 times its probability, which is 3/7, plus 2 times its probability, which is 2/7, plus the other one is 3 times its probability, which is 6/35, plus another one, 4 times its probability, 3/35, plus 5 times 1/35. Then if we can simplify here, what we get? 3/7. 3/7 is 3 divided by 7, plus 4 divided by 7, plus 3 times 6 is 18, divided by 35, plus 12 divided by 35, plus 5 divided by 35. you get 2. So that's the E of x. Then E of x squared. E of x then squared here. It will be, first you square the value of x. So it will be 1 squared times its probability, 3 over 7, plus another one, 2 squared times its probability, 2 over 7, plus another one, 3 squared times its probability, 6 over 35, plus another one, 4 squared times its probability, 3 over 35, plus another one, which is 5 squared, last one, times its probability, 1 over 35. Then if you can simplify this one, 1 squared, 3 divided by 7, 3 divided by 7, plus 4 divided by 2 over 7, 4 divided, actually let me just say 8 here. 2 squared is 8, so it will be 2 squared is 4 times 2 is 8, 8 divided by 7, plus 3 squared is 9, 9 times 6, let me say 9 times 6 divided by 35, plus then 4 squared is 16 times 3 divided by 35, plus 5 squared is 25 divided by 35. Then you get here 5.2. 5.2. Then to find our variance is equals to 5.2 minus 2, which is equals to 3. So that will be the variance, we can say, done. So it's not 3. 5.2 minus 2 is actually 3.2. Because 5.2, 2 minus 0 is 2. So it's 3.2. Then we can say done. That was the last question. Say Mangeya signing out. Say Mangeya signing out. Subscribe, like and share this nice powerful video. Thank you.